Speed. So speed is the distance that an object travels per unit time. Some common units include things like meters per second or kilometers per hour. This does not include a direction. There's actually a term called velocity that includes direction and speed. But speed is just how fast you're going without worrying about direction. A change over time is called a rate. So really, speed is a rate. It's a rate of change in location. A non-speed example of a rate might be a leaking water tank, which could be in like liters per hour or something like that. Now, our equation for speed is distance divided by time in seconds. So distance in meters divided by time in seconds gives us speed in meters per second. And a short version of this equation is S equals D over T, so speed equals distance over time. So some common speeds over here. So we have an Olympic 100-meter dash, which is about 10 meters per second. You have a car on a city street, which is about 35 miles per hour, which is about 16 meters per second. A car on the interstate highway, which is about 65 miles per hour, would be about 30 meters per second. Commercial airplane about 250 meters per second. Now, if you notice, looking at these numbers, you can get a quick idea of, especially lower numbers, meters per second to miles per hour, that conversion. So meters per second times 2 is approximately our speed in miles per hour. Okay, so 30 times 2 is 60. Well, 65 miles per hour, that's pretty close. 16 meters per second, take 16 times 2, that's 32, that's close to 35. So normal everyday speed, you can kind of think, well, cut it in half, and that's close to your speed in meters per second, to give you an idea about how fast that is, since we're used to thinking about things in miles per hour. Now, constant versus changing speed. So a constant speed means you're not speeding up or slowing down, okay? So distance over time for any interval would be the same. So the distance per time would be the same for any interval as long as you're traveling at a constant speed. However, speed is not usually constant. Sometimes we think about an average speed, but speed is not usually constant. We're usually speeding up, slowing down, etc. So speed changes as you start and stop moving, go up and down hills, slow down for turns, etc. So all that stuff causes a change in speed. So like for example here we have distance in kilometers that someone has driven and their speed in kilometers per hour. So you start off not moving at all, you speed up, so you're gaining speed here, so you're speeding up. Then you may have to climb a hill, which means you're slowing down, which is counterintuitive because this is going downhill, but it's going down because you are slowing down to go up the hill. Then maybe coming down the other side of the hill, you speed up, okay? Then you have to slow down and stop for a red light, so you get back down to 0 kilometers per hour for the red light. Then you speed up again, you travel at constant speed for some distance, and then you slow down and stop again. Okay, so this is just kind of a graph kind of showing over a certain distance how our speed is changing over that distance. Now, average versus instantaneous speed. And again, we still have the same equation here. Speed is distance over time. So average speed is simply the total distance divided by the total time traveled. Okay, so if you traveled for 200 kilometers, okay, so let's say we traveled 200 kilometers, okay, that's our total distance, and it took us 2 hours. Okay, so our average speed would be 200 divided by 2, which is 100 kilometers per hour. Okay, so that'd be our average speed. Now your instantaneous speed is your speed at any given time, and that's what's actually given on your car's speedometer. It's constantly changing as you're speeding up and slowing down, because that is your instantaneous speed. Instantaneous speed is changing, yeah, when you're speeding up or slowing down. It does not change when something is moving at a constant speed. So if you are moving at a constant speed, like you set the cruise control and you're on a nice flat road, something like that, you are traveling at a fairly constant speed, and your speedometer shouldn't change much, or at all, really. If you're traveling truly at a constant speed, it wouldn't change at all. This can be calculated using calculus or measured directly. It's measured directly on your speedometer. If you had a curve like we had in the last graph, you could calculate it using calculus, but we're not going to get into that.